We meet again. Today, we're going to be talking about solving rational expressions, or equations, excuse me. And we're just going to kind of dive right in. So, the idea here is I have an equation that has x's in the denominator of at least one fraction. So the trick here, what I'd like to do, is to rewrite these problems so that they're no longer involving any fractions, so that all the x's are going to be out of the denominators, and in fact I'll have no denominators anymore at all. But just like everything to be numerators only. So the trick to do that is I'm going to multiply both sides by the least common multiple of the denominators. Now, the way I find the least common multiple of the denominators is the same way I would find the least common denominators if these were things I wanted to add together. So I notice that both of my denominators, x plus 1 and 4x plus 5, are already prime. There's no factoring I can do. So my least common multiple of the denominators is just going to be the product of the two denominators. So I'm going to multiply both sides of this equation by that least common multiple of the denominators. So when I do that, what I get is 3 times x plus 1 times 4x plus 5 over x plus 1 equals 9 times x plus 1 over, oops, forgot to write the 4 there, 4x plus 5 over 4x plus 5. And now I can reduce each one of these fractions. So the x plus 1s can cancel, and the 4x plus 5s can cancel. And what I'm left with is just 3x times 4x plus 5 equals 9 times x plus 1. So I can just distribute things through. So 12x plus 15 equals 9x plus 9. And if I subtract 9x from both sides, I get 3x. And if I subtract 15 from both sides, I get negative 6. And if I divide both sides by 3, I get negative 2. But I'm not done. For all of these rational equations, we need to make sure we're checking our answer. But the check on these is very easy. All I need to do is check to make sure when I take my answer, negative 2, and I plug it into the denominators only, no denominator can give me 0. So negative 2 plus 1 doesn't give me 0. And 4 times negative 2 plus 5 doesn't give me 0. So this answer is okay. Let's do another example. So let's say we have 5 over x plus 7 over 4 equals negative 9 over x. Okay. So if I look at this, the first thing I want to do is look at the least common multiple of my denominators. So if I look here at my denominators, I see two distinct factors. I see x's, and then I see a 4. So the biggest power of 4 is to the first. The biggest power of x is just x to the first. So I'm going to multiply both sides of my equation by 4x. So when I do that, the 4x is going to distribute to both fractions on the right or on the left-hand side. So I'm going to have 4x times 5 over x plus 7 times 4x over 4 equals negative 9 times 4x over x. And here I can reduce, so the x's can cancel in the first fraction, the 4's can cancel in the second fraction, and the x's can cancel in the third fraction. So what I'm left with is 4 times 5, or 20, plus 7 times x, or 7x, equals -9 times 4, or -36. If I subtract 20 from both sides, that gives me -56 on the right-hand side. And if I divide both sides by 7, I get -8. But I'm not done. I still have to make sure I go back and check this. And when I go back and check, I have to check at the very beginning. If I plug -8 into x in my denominators, obviously none of those give me 0, so this answer is good. Okay. Let's do another. So hopefully you're seeing that these maybe are getting a little bit more complicated as we go, but none of them should be too bad. So let's look at this one. So again, there's no factoring to do in my denominators, so I can go straight to looking for the least common multiple of the denominators. Notice that the 1 doesn't have a denominator, so I'm just going to ignore it. And then I have a factor of x minus 5 and a factor of x. So my least common multiple is going to be x times x minus 5. So I'm going to multiply that to both sides of this equation. That's going to distribute. So what I have then is x times x minus 5 times 1, or just x times x minus 5. I'm going to have 8x times x minus 5 over x minus 5 equals 3 times x minus 5 over x. Now I'm going to reduce each of these individual fractions, so the x minus 5's can cancel, and these x's can cancel. So let's see, if I distribute the x through, I have x squared minus 5x minus 8x equals, I'll distribute the 3 through, 3x minus 15. So what I'm left with is a quadratic equation. So I'm going to start by moving everything onto the same side and combining some like terms. So -5x and -8x is -15x. If I subtract 3x from both sides, that gives me -16x equals -15. If I add 15 to both sides, I get x squared minus 16x plus 15. This is a quadratic equation that's equal to 0. To solve this, I can either use the quadratic formula, or I can try to factor this. Since the leading coefficient is 1, I'm going to try factoring. So I'm going to look for two numbers that multiply to give me positive 15 and add to give me -16. Oh, I see the two numbers. It's -1 and -15. So I can just rewrite this as x minus 1 times x minus 15. And when I set each piece equal to 0 and solve, I get x equals 1 and x equals 15. But I'm not done. I have to go back and check. So if I check 1, I go all the way back to the beginning. If I plug 1 into the denominators, that doesn't give me 0. So that answer is fine. Next, I'll check 15. If I plug 15 into the denominators, I don't get 0. So that answer is fine. So I have two answers. And I'm done. Let's do one more, and then we'll be done with this lesson for today. So let's say we have 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. So the first thing that I'm going to do is I'm going to look at the denominators and see if I can do any reducing. X minus 3 is prime, x plus 3 is prime, but x squared minus 9 I notice is a difference of 2 squares. So that can factor to x minus 3 times x plus 3. So I'm just going to write the factored form underneath it. So now, if I look at the least common multiple for all of these, well, I see I have 2 distinct factors. I have x minus 3's. Both of them are to the first, so I'll just have an x minus 3 to the first. And then I have x plus 3's. Both of them are to the first, so I'll just have an x plus 3 to the first. And that's what I'm going to multiply to both sides of this equation. So I multiply here. I get 6 times x minus 3 times x plus 3 over x minus 3 equals, and then this will distribute, so I have 8x squared times x minus 3 times x plus 3 over x minus 3 times x plus 3 minus 4x times x minus 3 times x plus 3 over x plus 3. So this looks pretty bad right now, but it's about to get a lot nicer because we're going to reduce. So x minus 3's cancel, x plus 3's cancel. And now if we distribute the 6 through, we end up with 6x plus 18 equals, the 8x squared is just by itself, and then if we distribute these through, I have minus 4x squared minus 12x. But this is not correct. Does anybody see the mistake when I wrote this down? Keep looking. There's one there. I didn't copy anything down wrong. So here is the issue. This is a minus sign. This minus applies to everything we get there. So really, that needs to make sure, or we need to make sure we're distributing that. So I have 6x plus 18 equals 8x squared minus 4x squared plus 12x. Ooh. So sneaky. All right, so let's combine like terms and get everything onto one side since we see that we have a quadratic equation here. So on the right-hand side, I notice that 8x squared minus 4x squared just gives me 4x squared. And then I'm going to subtract 6x from both sides. And then I'm going to subtract 18 from both sides. Now I have a quadratic equation that's equal to 0. Before I try to solve this, though, I notice that all of the coefficients are even. So if I divide both sides by 2, I can make my life a little bit easier by making my coefficients smaller. So to solve this quadratic equation, I can either factor or I can use the quadratic formula. I notice since the leading coefficient isn't 1, if I were to factor, I have to do that long factoring. So I think for this one, I'll use the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2 times a. So when I do that, I have negative 3 plus or minus 9 plus 72 over 4. 9 plus 72 is 81, and the square root of 81 is 9. So if I break that up, negative 3 plus 9 over 4 is 6/4, or 3 over 2. And negative 3 minus 9 is negative 12 over 4, or negative 3. So those are my two solutions, but I'm not done. Remember, I have to check these. So I'll take 3 over 2 and go back to the very beginning, plugging it in for x. None of those give me 0, right? 3 over 2 minus 3 isn't 0. 3 over 2 plus 3 isn't 0, so that answer is good. My other solution was negative 3. If I plug that in, negative 3 minus 3 isn't 0, but negative 3 plus 3, that gives me 0. So as soon as I see that happen at least one time, I stop, I cross that one out because that is an extraneous solution, and we need to make sure we discard that. Now, we saw that one of our two solutions was extraneous. It doesn't always happen where one works and one doesn't. They can both work, they can both fail, and one can work and one cannot work. So we don't know which one of those situations you're in. Every single time you have to check all of your solutions. They can all work, none of them can work, some can, some can't. You don't know until you check. So you need to make sure you're checking and being quite careful. But that's it for this lesson. For your homework, I'd like you to do worksheet 3 from chapter 9, and have a nice day.